We are going to continue our exploration into trigonometry by working on the fundamental identities and using them to simplify expressions and verify identities. Let's recall the properties that we learned in the previous chapter. We learned that we have reciprocal functions. Cosecant and sine are reciprocals. Secant and cosine are reciprocals, and tangent and cotangent are reciprocals. There are the quotient identities. Tangent is sine over cosine, and cotangent, the reciprocal of tangent, is cosine over sine. The Pythagorean identities tell us that the sine squared of x plus the cosine squared of x is equal to 1. Tangent squared of x plus 1 is equal to the secant squared of x. And then 1 plus cotangent squared of x is equal to cosecant squared of x. We then looked at the different even and odd properties. Cosine and its reciprocal were even. So cosine and secant were even, and then the other four functions were odd. When we are simplifying using identities, you want to think about what you're given. You want to try rewriting things. Should you use a reciprocal? Should you use a Pythagorean identity? Do you have something that is squared? Do you have something that could be rewritten using a quotient? So you want to try a few different options. Try replacing the function given with their reciprocals, or if you have tangent or cotangent, try the quotient identity, or if you have a squared function or something to a power, you can try using the Pythagorean identity. Let's talk about verifying identities now. There is a method to verifying trigonometric identities. You typically work with one side of the equation and try and get it to look like the other side of the equation, and you'll work with the more complicated side. Then you look for opportunities to apply the identities. So do you want to use the reciprocal? Do you want to use quotients? Do you want to use Pythagorean? Something like that. And then you can use either factoring or combining like terms, common denominators, or some sort of algebraic technique in order to simplify. And you can always try and write things completely in sine and cosine to see if that helps as well. Okay, so to recap, you want to work with one side of the equation, typically the more difficult side, using the other side as your goal where you want to go. Then you want to look for opportunities to apply the fundamental identities. If you have a product or a quotient, you want to use the reciprocal or quotient identities. If you have squared terms, you want to use a Pythagorean identity. And if you have negative arguments, then you want to think about using even and odd identities. Then you want to use algebra techniques such as factoring, multiplying, combining like terms, or finding a common denominator. And then finally, write terms explicitly in terms of sine and cosine if you think that that would be helpful. I want to help you remember properties of logarithms in order to be able to simplify when you have logarithms. Similar to your exponent rules, because remember, exponents and logarithms are inverse operations. When you multiply in logarithms, that is actually something that can be expanded using addition. When you divide, you can expand using subtraction. And when you have something raised to a power, that power becomes the coefficient. And these work both ways. If you have addition, you can combine them to be multiplication. Subtraction can combine to be the quotient, and if you have a coefficient, you can make it a power. And those are really all the techniques we're going to use. Very brief, but it just takes practice in recognizing which one, what approach you want to take. You'll recognize, oh, I should be factoring here. I should be combining like terms. And sometimes it's just a little bit of a trial and error until you become more comfortable using the different identities to help you simplify and verify.